So section B, we're starting to get into specific ways that we use the antiderivative, and that's finding area under the curve. All right, so notice this kind of spells out some specific things. F of x has to be positive. So this is all just for functions that are above the x-axis and continuous. Then the area bounded by the function, the x-axis in between a and b, the area just equals the integral from a to b of the function. So it's really important. We only say that the area is the integral if f of x is above the x-axis then when you take the integral from a to b, it's finding all the area between the curve and the x-axis. So you're connecting the curve itself, the x-axis, starting at A, going all the way to B. Okay, so the first example, it says find the area of the region enclosed by 2x, the x-axis, 0, and 4. So we need to graph it first to get a visual of what's going on. Y equals 2x is just a line. Y-intercept at 0. Up 2 over 1. I need to go all the way over to 4. Up 2 over 1. Up 2 over 1. So forth. Okay. So this is just a straight line. So we have the function. We have the x-axis. 0 is starting here. And x equals 4, you just bring wherever that's at. That was kind of crooked. Bring this point straight down to connect to this point here. All right. Now, so the shape of this, the geometric argument, this is just a triangle. What is the area of a triangle? 1/2 base times height. So my base is 4. My height, I'm just going to plug 4 into my equation. 2 times 4 is 8. That tells me my height is 8. So 32, half of 32 is 16. Okay. Now, we're going to define the same information using integration. Every time you hear the word integration or integrate, you need to write the integral symbol. We're going from 0 to 4 of the function 2x. So I just need to do my power, add 1 and divide, which is just x squared because the 2's will cancel. From 0 to 4, plug in the 4. X 4 squared is 16, minus 0 is 16. Notice we get the same answer. So sometimes they're going to want to see that you see how these tie together. If this is a straight line, that's the only time you can use area formulas, or if you have a circle. Okay, so find the area of the region enclosed by x squared plus 1. So in general, x squared plus 1 is just your parabola up 1. And we're going from 1 to 2. So I'm going to take this curve and connect. 1 is the beginning, 2 is the end. That's my area. All right, so we're going to set up our integral. We're going to integrate from 1 to 2 x squared plus 1 dx. Add 1 and divide, and 1x from 1 to 2. Plug 2 in. 8/3 plus 2 is my top value. Plug in your bottom value. So sometimes what I do, just because I make fractions a little bit easier, I'm going to distribute this negative. So I'm going to distribute the negative like this. Then I can do 8/3 plus -1/3 is 7/3. 2 plus -1 is 1. 1 is 3/3 plus 7/3, which is 10/3. Okay. All right. This is being kind of particular. This wants one arch of the sine curve. Now, be careful though. Sine of 2x. This 2 can be construed one of two ways. First of all, this means there's 2 regular sine curves within the period. The other thing we can do, 2 pi divided by k, this is how we determine period of the sine curve. So 2 pi divided by 2 is just pi. What that means is the period, where normally the sine curve takes 2 pi to complete that first cycle. What this is telling me is it completes that first cycle by pi. It also tells me I can have 2 cycles within the normal 2 pi period. Either way, oh, that's kind of interesting. What we're looking for is this first arch. All right, so if this is pi, this is pi over 2. So what this looks like is this is not a circle, this is the sine curve, so be careful. I'm looking for the area between the sine curve of 2, sine of 2x, and the x-axis. So this right here. So we just integrate from 0 to pi over 2, sine of 2x, antiderivative of sine, negative cosine, divide out the 2. So I'm just going to make that -1/2 from 0 to pi over 2. Plug in the top, -1/2 cosine of 2 times pi over 2 is just pi, minus -1/2 cosine 2 times 0 is just 0. All right, so if we're evaluating cosine, so cosine of 0 is 1, cosine of pi is -1. So cosine of pi is -1 times that -1/2 is +1/2, minus cosine of 0 is 1 times -1/2. So I'm going to add the opposite, and I get 1. All right, so what I'd like you to do is kind of look at this investigation and kind of work your way through. If you can just take a few minutes, work your way through this investigation. This is kind of interesting the way it uses area. If you recognize that some of these shapes, like you can break this up however you want. This is all using area. So if you see area of a triangle, 1/2 base times height. Area of a trapezoid is h over 2 base 1 plus base 2. Area of a circle is pi r squared. So in the graphs down here, you're going to use these areas and kind of figure out all the different little ways to get that integral value. But first, work your way through this part and think about what it's asking and interpret. Then we'll talk about this tomorrow.